Okay. It looks like we are live. Okay, then it's fine. So now I am going to go through what's happening there. Okay, I'm going to go through these type of equations where you need to simplify. Um, hmm. Okay, maybe, what I'm going to do, it will just to browse through this because it's similar to what I've already done, where let's say you have this, where you minus 1, this is being divided by 2 to the that, minus 1. If you remember, I have gone through this one where I was saying, the moment you have minus 1, and somehow this side, there is a 2 there, whereby this thing can be written as that, nay, minus 1. It should therefore remind you of the difference between two squares. Because 1 squared, it is still the same as 1. So that's why we say difference between two squares. So you see now, this is the same as that. That's why you can do that K method. Otherwise, if not the K method, you can work it out as it is, where you factorize and all of that. Yes, so what about when you are having 2 to that same thing, minus 1, but this time around here, you are given 2 and then it's a plus 1 there. Trust me, you follow this same process, things will work themselves out with that one. So, okay, let's see. What if now it's 9 to the that, and then you have 9 minus 3 to the that, and then that. All that you know is that this thing, maybe write it as that, where you are having that, and then again, is it not these that you are having, where you are having that? Then from there, it will still take you back to the difference between two squares. Can you see 3 squared? And then over the whole of that. Then you know what to do with this. And then once you've dealt with it, then you will see it will work out nicely with that. Not that much complicated, honorable member. Doesn't matter if you are having 16 there, maybe this time around, they minus it by 4. Someone is calling there. I will just do that. Okay, maybe this is being divided by that to the that, where we minus, let's say, maybe that. Something of this nature, honorable member or a member who is honorable. Whereby now, this definitely, you might find that it is the difference between two squares, where you might be having that, maybe that to the that. Why does it look like it's a bit... Okay, why not rewrite this thing as that to the that? Nay, somehow you manipulate it so that this exchange, that goes in there, that goes in there. Because it's like you end up having 2 to the that, and then you now rewrite it as a 2 to the that, and then that, just so that you can have this square. And then you'll say the difference between two squares. This one again, you might maybe need to rewrite it as 2 to the that for it to remain as 16, so that, okay, you have a... Nope, it looks like you won't need to take it back to there because it's no longer the difference between two squares. It is now that. So it looks like you leave it as it is. Then you end up having 2 to the that, where you minus, is it 4 squared? Yes, now is the difference between two squares. Deal with it decisively. Somehow it will deal with that. So now let's get to the powers with a rational exponents. I'll just do a few examples there. Let me see if after doing these examples, I'm going to be having something for you. Okay, I think I will. So now let's say we are having 8, nay, which is to the exponent of 2 over 3. So if you don't know what a rational number, then it means which means you might need to go back to the lower grades to try and find out what a rational number is. But even if you don't know, because I think I also got to grade 10, I don't think I knew what a rational number is. 11, even 12, until I made a decision in grade, somewhere in those grades, to redo everything that I did in 8 and 9, and then come with them nicely. But otherwise, even though you don't know, but you will still be able to get away with it. But let's see. Okay, 8. Is 8 not 3? No, 2 to the 3. Then it means you have that and that. Therefore, you have 2. This thing multiplies that. You have 3 multiplying 2 over 3. Definitely that cancels with that. Then you end up having 2 to the 2, which will definitely be 4. So that means if you punch this on a calculator, expect to get 4. If you don't get 4, it means okay, here's an interesting one, honorable member, where you are now given 0.25. Your decimal, okay, and then they say this is to the exponent of 3 over 2. Yo. For me, what I know is that 0.20 or 25 is a quarter because 0.5 is half. And a 0.75, I think it's a, what is it? 3 over 4, 3 out of 4. Otherwise, if you are not like me who can somehow interpret the decimals, just punch it on a calculator and say 0.25, say equals to, and then press the SD button. It will give it to you as 1 over 4, which means actually you are just having this thing, honorable member, because what we know is that we don't deal with the what is it? The decimals when it comes to this simplification. So in other words, according to me, it means you have this thing. Do you not have 2 to the 2? I think this is what you are having. Obviously, that remains. So again, this thing should be the same as that because you are now writing it like that so that it will somehow work out with that. Whereby you can say now you have 2 to the exponent of that -2 multiplying that 3 over 2. Whereby now that cancels with that, and then you have that multiplying with that, you end up having 2 to the -3, whereby this is now equals to 1 over 2 to the 3. We don't want a negative exponent. That's why you have to rewrite it this way. I hope that part makes some sense. So yes, I've got some nice work for you to do. Learn from there. Maybe for now, let's see if we can get to the roots. Let's see, can we get to the roots now, or can we move it on the next lesson? I think we can move it on the next lesson. Yes, I definitely think we can move it on the next lesson. Let me just verify here. Because that one of the exponents with the rational numbers, I think they we've dealt with it decisively and nicely. Maybe let me make use of this time to introduce you to the roots and sets. Just the roots and sets. Yes. Okay. Something that you need to be aware of, honorable member, something very much important to say, the root definition. The root definition says if you are having n to the square root of a being the base to the exponent of that, this thing is the same as that same base. Now you see this exponent is the one that goes to the top or as the numerator, and then that n, it is the one that goes to the denominator. This alone, it's a root definition that you should always make sure that you never forget, which means if you are having 3 square root of 8 squared, this thing is the same as 8 to the 2 over 3. That is why when you have square root of maybe, let's say, x, maybe to the 1 there, doesn't matter. always when it's like this, you have invisible 2 there, always. Just like when you have x, you have invisible 1 always. So that is why this can therefore be written as that x to the exponent of 1 over that invisible 2, which explains why they say for you to remove a square root, you must square that square root. The reason for that is because it is the same as this thing when you have square root of x. And then when they say you square it, it's like that square, it therefore multiplies that exponent, whereby that 2 will cancel with that, and then you end up having x. So that's how we remove the square root by a squared over there. I hope that part makes some sense. Okay, what else can I now talk about? Because it looks like all that I've explained, yes, all that I've explained, uh, it's as easy as that, honorable member. You see, now I don't even have some problems to give because it is that easy. If you are having a nay to the exponent of 2 over 5 in reverse or in a form of a square root, this thing it means is the same as 5 square root of a2. So it can be taken back to that. Just be careful of that. Which means, again, if you are having x to the exponent of 4 over 3, this thing should therefore be the same as 3 to the that and that. So that's you doing it in reverse, or the reverse of it is that. Okay, maybe let me do some problems now. Let me do some problems now, whereby let's say we are having 4, nay, we are having that 4, which is to the square root of 625 being divided by the 1, and then there we have 3 there. Yes, let's look at this one, because sometimes dealing with the square roots can be a bit tricky, but trust me when I say you are back to the loss of exponents, because what we know is that this thing, it is still the same as exactly as it is, except now we rewrite it as this going to the top and then that being there. I hope you would agree with me on that one. So if you have that nice calculator where you can say, for example, you just punch what is it? That 625, you press equal sign. You click on shift. Can you see? Next to negative, you have FACT. The button next door. When you look at the writing above that button, it's fact. You press on it, it will therefore give you that 625 is the same as 5 to the exponent of that. You do the same with 81. It will give it to you on your calculator as 3 to the exponent of 4. But just remember that you still have that. Hope that part makes sense. You remember the law of exponents, which says that multiplies the exponent of that and also for that. So that means you are having 5 to the 4, which is multiplying 3 over 4. Again, same happening here. We have 4, where the 3 multiplies with that. Then from there, that cancels with that. You end up having your 5 to the 3 over your 3 to the 3. And I think this thing, it will definitely be 125 over 27. So that means, honorable member, if you punch the whole of this on your calculator, it should give you that. But you don't punch it in an exam, a class, a test, whatever the case may be. It could be assignment or home. You prove it by means of calculation. Very, very much important there. The reason why you have to prove it by means of a calculation is because they are going to give you this thing now in a form of letters. And when it has the letters, trust me when I say, or say if you cannot be able to move this one, honorable member. So let's see. What if you are given 3 inside the brackets? Then it is again that over 8, which is multiplying x to the 12, which is multiplying y to the negative 6. And then we close the whole of this. Then we say to the that. What an interesting question. Looks scary, but trust me, you can't say scary and then you pass it and you jump onto something else. What are you going to do if you haven't done this one? We deal with it and we deal with it decisively. Okay. The first step, at least, it should be easy because we know that maybe let's not waste our time with this one because I know that you might be worried about that one. They told you to say, if this is a whole number, you multiply it by that and then you plus it by that. Is that not what they said? You can still punch it on your calculator as a whole number there. How you do it, you can just say shift, you click on that button for the fraction, that one of the over. Then you'll say 3, you go to the side, you do 3, at the bottom, you say 8. Then it gives you something which is the same as that whole number times denominator, it gives you 24, you plus it by that numerator, it gives you 27. Then that is why it ends up being 27 over 8. Obviously, multiplying that to the that, and then multiplying that to the that, even though we don't want a negative exponent, but we'll deal with it on the next step. So I think now we have done what we could do. Yes. Okay, then it's fine. 27, I don't know, but 27 is 3 to the 3. I'm not sure if you are aware of that. Multiplying by 12 to the that is fine. So I'm concerned about that y being a negative. So that's why I'm writing at the bottom as a positive of that. But this 8, can we just not rewrite it as what we know 8 to be? Think we know 8 to be 2 to the exponent of 3. So we don't waste time, but straight away we just do that. Okay, you know, Mos, the law of exponent. It says you multiply this by that and again that. And you still do the same with the numerator. We're just applying the laws of exponent. So now we have 3 to that 3, which will have to multiply that 2 over 3, which has to now multiply the x, having the 12, we multiply it by 2 over 3. Then the whole of that, you will therefore divide it by, you have 2, and then you have 3 that you multiply it by that 2 over 3, where you have your y, you've got your 6 there that you multiply it by that over that. Okay, so now let's see, that cancels with that. We just enjoy canceling there. And then here, I think this goes into there 4 times. So it's like you have 4 times 2. Is it not 8? I think it's 8. It has to be 8. That being divided by that cancelling with that, it's like you have 2 to the 2, and then that goes into that 2 times. So it's like you have y times add into that is 2. 2 times 2, it has to be 4. Yes, something of that nature. And then you might need to trust me when I say 3 squared is 9. And again, 2 squared is 4. So can you see, you've just dealt with it decisively. But for you to come in, let's say you are in grade 12 as an example, and you say I have problems with simplifications and all of that, but you don't start where it starts with, which is the introductory session, then you're going to be in a big trouble, honorable member, because these things, they start from somewhere. And if you don't start where they start, then definitely we are going to have big problems there. Yes, I think I've done enough for now. On the next lesson, I will therefore introduce you to the sorts. Introduce you to the sorts. Very, very much important there. very, very much important, honorable member, that get to be introduced to the salts. Not that much complicated, but for now, I think I'll leave it here and say until we meet again. Until we meet again. What do I do? I think on this topic.